question. This is how I'll do it. I saw that all these groups are at meta position. And I know very well this has a multiple bond. This is meta director. NO2 also has a multiple bond. This is also meta director. But this has a lone pair. This is an orthoparallel. Before starting the question, I knew this. Step 1 clear, what I did. Step 2. I learned that this is called Friedel-Crafts reaction. And I know that nitrobenzene does not do that. Nitrobenzene failed to do this step. That means the first meta director which can be moved into the benzene ring is acylation. Because if I put nitrobenzene, it says, oh, I do not do FC reaction because I'm so slow. I don't know what FC reaction is all about. So I said, okay. I did acylation. In AlCl3. It attaches this to this carbon. Doesn't matter which side you write. Now this is a meta director, then I did nitration. Because I wanted every group at meta position. Now I have two groups which are meta director. Now I did chlorination. It allows the chlorine to come in this position. And then I added H2PDC. It reduces this to CH2, this reduces this to NH2. Clear? This is one way of asking the question. That I give you the reagent and you have to put the order in which they have to be added, right? Everybody's understanding this question is all about? Now, I brought the second version of that also. What if the question is given, do the synthesis, and they give you a list of reagents like this? Answer is the same. Now, question is complicated because you gave me bunch of groups on that side. I have to be careful which one to pick. So the one I gave you in recitation is easy question. The one I give you right now is, you know what this reagent does. You know the idea of these reagents. Right? But I want to practice. Do it this way also. So that you will say, oh, I remember the reagents to be done. I just brought the different. We'll talk about these questions, don't worry about it. Next. 4-step synthesis. First thing I thought, they give me the list of reagents. I'm an orthoparadirector. I'm an orthoparadirector. And I'm also an orthoparadirector. What the heck? Yeah, we all are orthoparadirectors. I'm the best activator. If I'm the best activator, activator, I will allow any electrophile to come at my para position. And problem is that I don't do mono substitution ever. Because I'm a very strong activator, very strong. That clearly gives me that this is the last step. Because otherwise this is Roux synthesis. Next. What did you see next? I saw the next thing is that this NH2 is ortho to this group. Am I right? That means you must have blocked its para position first. Do you agree? Right? You must have done this reaction first and then this reaction. Because ortho is only formed is para is blocked. Otherwise it goes to para. Because of the steel reasons. Everybody understanding the process I'm thinking on exam? Okay. Now, that's my thought process. They gave me isopropyl chloride in KLCl3. I said, let me bring this. But I saw that they did not give me ethyl chloride. They never give me. Do they ever give me? Even if they give me, I'll never use it. Because this guy undergo polysubstitutions. If I use directly like this, it is a polysubstitution reaction. 100%. You can't give monosubstitution to this reagent. Methyl, ethyl, bad. Then what did they do? They did acylation of this. And since para dominates, this guy brought acyl at this position. Now its para is blocked. Everybody saw the para is blocked now. Now say, oh, what if I use nitric acid now? Because para is blocked, nitro has no option. It has to go ortho to this guy. But the synthesis was ethyl and NH2. I know where this comes from. This comes from here. I know where this comes from. How do they come from this H2PDC? How do they come from this H2PDC? Oh, then you added H2PDC. It reduced nitro to NH2 and this to it. So this was the synthesis. What 4 steps would you do? So I'll say, oh, I'll first add isopropyl, then I do acylation because I want to block the para position, because I want the next electrophile is forced to go at ortho position of the isopropyl group, and then I reduce them both. Clear 3 steps? Then I said, let me give 6 steps synthesis to them. I exactly use the same one, but I added 3 more steps to get this flow. Now this you can do retro. You said, fluoro, where are you coming from? I'm coming from diazonium salt. Backwards. Diazonium salt, where are you coming from? I'm coming from NH2. NH2, where are you coming from? I'm coming from NO2. That's the process. And in the recitation, I already told you how to bring NH2. You see how I'm making a list of my reactions? I know in the whole chapter 17, they did not teach me how to get fluoro. They only taught me how to get fluoro from diazonium salt. And I said, oh man, they want me to get to the diazonium first. And then said, diazonium, how do you get there? Oh, I came from NH2. And NH2, where you come from? Oh, I come from NO2. Now the synthesis is too easy for me. I've already made NH2. So my first 4 steps is exactly same what was in reservation. Because I reached NH2. Remember that? Right? And then I said, okay, now they want me to add NaNO2, HCl, 0 degree, diazonium salt. Right? And then they said, then I said HBF4, negative, positive, negative. They give you this reagent always. This is given, this is given. Now, I just want every one of you to now do the third one with me again. Now, let's everybody go to the second. Everybody understanding how I'm processing the steps? Is it making sense? And everybody is making sense? Why I stopped? Why did I stop like that? And why I'm thinking like that? Do not process the synthesis by looking at it. It will be disaster. It will be disaster because you don't know where to start from. So just connect the dots first. Then where is this all coming from? And you will always see there's a clue. And you say, oh, I get the clue. What's the clue? It's all catching the clue of the first one. Good? Okay, next one. Again a 4-step synthesis. I always feel dye-substituted synthesis is harder. Dye-substituted synthesis is easiest. Because I just have to think one step. And then I just have to follow up with that. So to do this question, I just asked myself, well, how did I learn in this chapter to get Cl? Diazonium. There is no second reaction you taught me to get Cl. How is diazonium coming from NH2 or NH2 coming from NO2? Done. Finished. I know what's going on now. Now I said, okay, first you must have done nitration. Tert-butyl is such a bulky group, it must have directed nitro to go its para position. Then you added H2BDC. H2BDC reduced NO2 to NH2. Then you must have added diazonium salt. You prepared the diazonium salt. Then you added CuCl. Did they give you all the reagents? All the reagents will be given. You do not have to worry about any reagent. You just have to recognize what they're doing. What if they could have added H3PO2 to diazonium salt? They get the reactant back.
What if you switched number 2 and number 4?
Then the points will be deducted.
Oh.
You cannot switch any of these. Any. So if on exam, I must tell you the grading. If you're, let's say, you forgot the first reagent, but you know what 2 and 3 does. Write 2 and 3. Because the points will be all 4 full points, correct 3, 6, whatever the points, correct 2, correct 1, has to be in the same place. So what they expect is that, okay, you forgot the first reagent, forget it, but you know where it is going. That's why I teach you backwards. That's why I teach you backward, take points. You know where it's coming from. You know which is this is coming from, right? And then you stop. I don't know after that. But I get partial credit. But if you write that, oh, you write 3 to 2, 2 to 1, then you're guessing. Then they won't give you points. Right? Because why guessing has big problem? Because it changes the data. It changes the statistics way where I want to see what question was bad, what question was good, which question student did well. So when this is done, we also study how you did, how the exam was, I wrote the exam, or we all wrote the exam together, and then say, oh, this was a problematic question. The way I tell you, you see this question? This question was one of the exam questions in one of the exams. It was bombshell, very, very bad. The moment I saw it, and I said, kidding me, guys? Try substituted 80 minutes. We were expecting that. But we are a team. Sometimes one person said, no, I like this question, I want to give it. Okay, give it. And immediately pulled it out and said, I'll use in a recitation this question because this has a lot of layers in that. Every layer student has to understand what the heck is going on here. Right? So these kind of questions will never be there. I'm not in favor of these kind of questions on exam. I always found that somewhere there is a connection moving. So then 80 minutes I can get the connection. Oh, I get it what they're talking about. Right? So that's what I'm saying. This is just a good practice. But these kind of questions will definitely clear up. So now, I gave one more question to you. How many students can, this is my list of reagents. How many students can do this question? I'm waiting for everybody to do 3 right now. You have think that this question is on exam. How would you process it? I'll tell you the questions. I give this question to my other class. To see how 308 does this. 5 steps. There are layers into that, that's why I brought it. If you finish, you can raise your hand and you can tell me that I would add these ones. Step 1 this, step 2, I'm more than happy to understand what the heck is going on so that you understand the concept of it.
So, step 1, I add the first, the right side.
Oh my god, I get it, where it is the problem. I'm writing them A, B, C, D because I wrote 1, 2, 3, 1, 2, 3 and B, C, D, E, F, G, H, I, J. Now makes sense, right? I know, it was all over the place. Yes, go ahead.
So then, the first one would be B.
Very good,
because
I
B
agree
and
with you,
then
B,
director.
yes,
And then C,
that's right, I agree with you,
to get your NO2.
yes,
Then reduction D,
very right.
add your G to get the
Resonance salt,
and then you add H2O and E. to get
that's
the-
right. Yeah, absolutely correct. How many students got this answer right? Awesome, I'm so proud of you. Make it good, very good. I'm so proud of you all. Very, very good. So first step is I'll add B, acylation. Then I add nitric acid, metanitrate. Then I add H2PDC. It reduces both Then I go to diazonium salt by adding G. Then I add J, water heat brings phenol. Good? Now, is synthesis making sense to all of you now? Yeah, do. This one I just wrote the same question from the recitation. I just wrote that. That question can be asked in another way around also. It's the same question. Now my next question is this. 5 minutes. Classify activators which are orthopara directors. That's what is your list is. Deactivators which are orthopara directors. Deactivators which are meta directors. And I gave you bunch of molecules or ions. 5 minutes. I'm writing numbers so that we talk in terms of numbers. Oh my god, oh my god, oh my god, the slide moved. Oh my god, I was that's sorry about that. This was also a recitation question. I just tweaked this little bit tweaked it. I said, okay, let me just ask this way, this question. Question number 5, CF3. Anybody ready? Go ahead here.
For one, it's activator.
Mm-hmm.
Director.
Tell me the numbers.
For one, it's A.
Mm-hmm.
For two, it is also A.
Mm-hmm.
For three, it is C.
Mm-hmm.
4 is A.
Mm-hmm.
5 is C again.
5 is?
C.
Okay.
6 is B.
Mm-hmm.
And 7 is C.
C. How many students agree to this answer? Anybody has a different answer?
Is it two a deactivator? Isn't two a deactivator?
I agree with you. But 2 goes here. That's my answer. How many students got this answer? Okay, let's do it. Whenever they give me this question, I don't listen to them. I make my bonds. I can give my lone pair. You're an activator. Orthopara director. Why you are orthopara director? An activator because my resonance dominates over inductive effect. I'm withdrawing. Everybody saw double bond was there next to it. Whenever I see a double bond next to the ring, I say, no, it's withdrawing. I'm a matter director and deactivator. I have nitrogen with positive charge. Yeah, you are withdrawing. Due to inductive effect, you are matter director. Withdrawing due to inductive and resonance both. I'm donating. I'm an activator, orthoperidirector. Resonance dominates over inductive. I'm withdrawing, inductive. I'm a matter detector, deactivator. I'm a problem. I'm donating, orthoperidirector. From an inductive effect resonance, so I'm a deactivator. That's why I'm a deactivator. I'm withdrawing, matter director, deactivator. Resonance, induction, both explain the same story. This is how I made my list. I don't have to memorize any group. None. You may give me anything. I know the meaning of donating, I know the meaning of withdrawing, I know the effect, and I just made my list like that. So the one I gave you on the notes, it's written, resonance dominates over inductive. Inductive dominates over resonance. If you look at the list, it's written there. That what is the reason for them to be activated? What is the reason for them to be deactivated? I just applied that list on these examples. Do I have to do 20 examples after that? Nah, I'm done. I know it's better. I'm going to do an exam. I know it. So I'm not worried about this question at all. Because I know this question very well. Because I can process it now. Everybody got it? Those who are struggling on somewhere the points? Yes? Is it making sense? Good. This is my another question. I give you two reactions and I want you to give me monosubstituted product or no monosubstituted. Let's do it together. This was a question also be given an exam, not yours. Recent exam somewhere, and the student, I want to see how much you had asked on this question. Because it is a good class. They're good, they work from here. So I feel they'll do it, this question very well. Both the questions were asked on exam. Not yours, of course. I gave you similar questions on my notes. So do every try problem because that's kind of a good way to practice the things. And I've already posted some of the problem because today is optional day, right? So I'm supposed to give the answers before that. So I've already posted what we discussed in the previous lecture. But I gave you the homework. They're already there on my slides. It's written try problems, lecture this. So all the answers are there. I think one I forgot to give, I think probably, I don't know. I just have that I have to give these ones. Mark them. Yeah. Who's ready? I'm writing the words, some positions, so that we all can talk. A, B, C, D, E, F, G. A, B, C. That's better. Where do you think monosubstitution product will be there? Who's going to help me? Everybody knows the product is NO2, right? Right, no? So where do you place NO2 now? to decide.
Is it B over A because there's less therapy?
B over A. I agree with you. Awesome. And his answer is right because of the steering problem. So now carefully look. It is not a difficult question at all. I just have to draw. I'm a donor. I'm also a donor. I'm also a donor. Everybody saw what I'm doing? But we are donor because of inductive effect. I'm donor because of resonance. I win. I'm the best. And look at the other ring. Oh, I just have donors due to inductive. I'm the best ring. You see what I did? Every carbon is a donor. I did not put methyl group, right? But I showed them two carbons. Every sp3 hybrid carbon is a donor. It is donating in either directions. So this is the only ring which has donating group because of resonance. I said this is going to control the reactivity. Okay. My para is blocked. I have two ortho positions. But this has steering factor. More steering factor. Because it is between two groups. Then I win. I place the NO2. That's it. What is this called? Directive inference. How many students got this answer? Raise your hands. How many students got the other way around? C. Lot of students do C because they feel there are two donating groups. No, hindrance. Hindrance is the problem. Right? Next. Where do you place A, B, C? This is the kind of question we can get on our exam, not this one. This is not 308. That's 308. Where do you place A, B, C? B. I agree with you 100%. How do you know this answer? I place the lone pair, you're donating, you're withdrawing, resonance dominates, you are the best. You are the one which is controlling the reaction. Your para position is blocked. You have two ortho positions. This is a steering factor, so let's do it here. How many students got this answer? Raise your hands. Awesome. See, I told you this is my honor students. They had exam last week. And we give them these two questions. Everybody bombshelled this one. Because everybody put it here. And the logic was very simple. Oh, two donating groups. They completely forgot that, steering factor is going to come along with that. But don't worry, we are not going to get anything like that. Don't worry at all. But that is what the level we have. Right? Good. My next question. Mechanism-based question. I said, this is the product of the reaction. Can you give me the best Lewis structure of the electrophile? Can you draw the most contributing structure of the intermediate? Period. I don't want mechanisms. I don't want arrow pushing right now. I don't want you to mess right now on the arrow pushing story. I want you to just give me two important structures. And then we write, after this we'll write learning goals of chapter 17 together. It's going to take time, so take your time. No rush. Can I see the notes? No. No. Because you have to think that, can I process it? If I can't process it, I'll go back home, review this again. Because it's not getting processed correctly. Very good. Everybody try. I did this similar reaction in warm-up. So if you are coming regularly in the class, please do not forget to do warm-up questions. They are very, very close to what we get in the exams. You understand that? So go over these questions. If you still have problems, come in the office hours. I will be here after this. I will be there in Bush from 2:30 to onwards. So I'm here till 5:15 today, reviewing everything. Tomorrow, anybody wants to review and attend the review, you can go to before the exam. Professor Zan class is from 5:30 to 7. Go. Right? It helps. The more I learn, the more I listen, the more I get confident that I know. So go and review with her. Right? So she's going to review tomorrow. And all the professors, they will be available tomorrow. Did they post the pre-exam officers? Yeah. I think Tuesdays a lot of people are there. Yeah. Because I can't go on Tuesday because I'm full on Tuesday. I won't be able to do the exam proctoring also tomorrow. Tuesday is my busiest ones. When you make the positive chart, no, I'm just going to off this animator.
So that is a positive charge. So see that? Where is my you see that? You have to keep this side of it. Doesn't enough. You are this again. That means the positive charge has to come this side. You all need to know. Yes, that's the thing you guys do on exam. You get extra marks. Don't do that. So you are gone. So I'm just thinking this is gone. No positive charge. That's right. No bond. That's right. No bond.
Did you read my question? It says best Lewis structure. That's the problem. That's where I've seen you guys make mistake. So I'm writing the best Lewis structure and you guys have to check if did you make the best Lewis structure or you did not make the best Lewis structure. I'm erasing this because we don't need it now anymore. First, I am sure about that, and this was good. So this is my loss. On my scrap paper, I made this. But the problem is that this is not the best Lewis structure. Which is the best Lewis structure? When this guy comes in and completes the octet of every item. This is the best Lewis structure of the electrophile. Will I be giving the points for this one? Of course, but partial credit. You will not get full credit. The full credit will be given to the student who wrote that because that's the best Lewis structure. Why that's not a best, this is not a best Lewis structure? Because this carbon has 6 electrons. In this case, all atoms have 8 electrons. That's why that's the best Lewis structure. Then what did you say? Show the intermediate best. So I'm not very good at making intermediates, right? So I like this way. I go here, kick out this guy, and give positive charge. This bond is between these two. So what do? Or this still on my scrap paper because I don't know how they ask me. So I put positive charge here, make a bond. This is the new bond. It's C double bond. That's what happened. Next step. Did you touch any of the other carbons? Of course not. There were two more carbons. I just drew them the way they are. Is this the best contributing structure of the intermediate? Of course not. I pushed the electrons. This is my rough work, guys. Now, one student says, I am very slow at understanding concepts. I don't like the way you guys start drawing everything. That messes up my life all the more. So that student says, I made like this, what's wrong in my answer? Absolutely, you're doing correctly. Other student says, I am good at, I think I understand what the heck is going on, I practice a lot. So that student from here start making the best structure. I come here, you go here. You see what I did? And this student said, I wrote it like this. I made a double bond with OMe. I made a bond here. This bond I didn't touch. So where are you doing the process? I'm doing the process here, here. And other student says, no, I just made like this. Will it be wrong? Absolutely, you're doing the same job, but you're going slowly. Because that's how you learn. You don't have to chase other person. You're doing exactly the same thing what the other student is doing. Because you both are giving me the same answer. And that sense. And I said, oh, first I put positive charge. They want the most contributing structure. Which is the most contributing structure? Where all atoms have their octet complete. Why this is not the most contributing structure? Because this has 6 electrons. Will I be given partial credit? Of course. But not full credit. Because you did not draw what the question was asking. So now everybody understand why did I say 4th contributing structure is the most one? 4th contributing structure is the most one. Right? Because we do ask that question. Or on recitation, what did I do? Because they had time, I said, tell them to draw all and circle the one which is more stable. You see what they did? Yeah. Positive charge can be on either side. My bonds are like this. So I use this bond as a donor. So if I'm using this bond as a donor, my positive charge will come here. If you drew the molecule, if you would have drawn like this, then your positive charge is here.
So others not.
Yeah. Either one is correct. Either one is correct. I just wanted the student should not get confused that, oh my god, what she's doing. I just want them to focus on that double bond. And so, okay. Go any direction, your answer is the same. So go slow. Right? Many students says, oh, I get it. Some students say, no, I don't get it. I just get the positive charge. Say, go slow. Go to the next. This is your rough work. On exam, you just have to make any of the circle ones, like box ones. That's what you did in the on your scrap paper. That, oh, they don't want me to make all, right? Now let's do the learning goals from this chapter. Every student who do this chapter must know the difference between aromatic, anti-aromatic, non-aromatic. Do the textbook problems, do the recitation problems, do the try problem, do the warm-up problems, became a lot. 2. Naming compounds. To the extent you should know ortho, meta, para, should know what is 1, 2, 3, 3. IR, NMR, characteristics of aromatics. Benzene ring, only benzene ring. Donating groups give proton NMR upfield. Withdrawing groups make proton NMR downfield. IR, aromatic C double bond is anytime between 1500 to 1600. Aromatic CH bond is anywhere between 3000 to 3150. CNMR, this is I wrote with my notes so that I don't forget there. Anywhere between 100 to 160 ppm. That's it, I can't do beyond that. Where do these protons come? Anywhere between 6.5 to 8.5 ppm. 4. They undergo electrophilic aromatic substitution. I wrote all the 5 reactions. Halogenation, importance, electrophile, intermediate, mechanism, nitration, same answers. What is the importance? Everything. Sulfonation, Friedel-Crafts, alkylation. In this I wrote limitation a lot. Importance and limitation of this reaction. Rest is electrophile intermediate mechanism. Friedel-Crafts acylation. Limitation. And rest is all importance, blah blah blah. Then 5, directive influence. Six, two substituents present. If both are donating, better donating controls. If one is donating, one is withdrawing, donating controls the reactivity.
Professor,
Yes, dear?
when you say the better one, you mean the one that's like
More
active?
donating, yes. Let's write the word more only. Situation 3, if they give me both withdrawing and one is halogen, and other is better director, halogen wins. If I have 2 withdrawing groups, both are meta directors, less withdrawing controls. We never reach to this situation. I never give. This is the worst situation I give. Which one do you like? I mostly like 1, 2, and 3. That's it. And in this case also, I will give you resonance versus inductive. I will never give you between resonance and resonance. Whoa. That's again brutal. Because I don't want you to memorize too much. Because that's so much of memorization, right? I have to memorize this are stronger, this one. Like, no. Learning goal is they should recognize which is donating, withdrawing. Right? That's my learning. That's not okay. They have to know this is high, this is low. I gave you so that if you start doing the question, say, oh, I get it why the answer is like that. 7. Oxidation of alkyl benzene. I wrote all the oxidizing agents, requirement, benzenic hydrogen, at least one CH bond. Oxidation KMnO4 on dichromate, this changes to COH. Then other oxidizing agents. Oh, battery finished. Can you guys hear me at the back? It's okay? Chromium trioxide in acetic acid converts benzenic position to ketone. MnO2 only oxidizes alcohols, not. So I made a list of oxidizing agents. I just taught you 3, only 3, KMnO4, chromium trioxide, acetic acid. These one we did alkyl benzene, this is for alkyl benzene. And this is for additional reaction we did. 8. What happens when alkyl benzene is treated with NBS, light, or NBS, heat, and radical initiator? You get bromobenzene. 9. Diazonium chemistry. NO2 to go to NH2 and NH2 from diazonium salts, and diazonium salts can do wonders. So I made list of reagents with products. So once I look at these learning goals, then I go to the try problems, then I try. So how would I process the try problems? I'll tell you if this is it, chapter finishes here for the exam. Now I go back to the try problems, which I gave you for this. Look, I gave you 2 try problems to work onto the diazonium chemistry. I'm not going to answer, but every one of you, I've already posted the answers for these. So that you said, oh, I processed it, let me see what the answer is. I'm not going to do it now. But when I start reviewing it, I wrote this, all together. So that I can do this synthesis on my own and say, okay, I get it what these reactions are talking about. When I made the list of reactions, whenever I made the cyano, I said, oh, they can always give me answer. That's why I always give you the importance of the reaction when I write the synthesis. I said, oh, how do they revisit this place unless and until I give them something. So I gave you a synthesis. I said, oh, but I don't want CN. I don't want benzonitrile, but I want benzylamine. And then I said, oh, we have learned H2PDC. So can I use H2PDC? Of course. Will you be giving lithium aluminum hydride? No. Why? Because exam 2 will bring it. I'm not in a hurry. I don't want to stress yourself that, oh man, a new reagent. Exam 1, remain with H2PDC. I'm good with that.
If you're given catalytic hydration and zinc chloride, which one do you use like in the synthesis?
Both. Either one of them.
But like,
I'll never mess up with both. If I understand what you're saying.
Oh.
If I give you zinc amalgam HCl and I give you H2PDC, I will be the brutal teacher. Because I'll give only one. Because then I'm confusing you more. See, testing does not mean making you uncomfortable. Testing means how to process the things in a lesser time and feel confident about it that you know it. So I don't believe in that. That give them some question which says, what the heck? No. Even the graph questions, I'll give you that, okay, these are the two graphs. What do you think is going on? Right? And you say, no, I know the number. Numbers, as I told you, if you know the numbers, those class questions will be, those NMR questions will be like this. You just have to look at the numbers at the bottom. Where are they? And then you say, oh, I get it, what they're talking about. So that is the part which I'm worried, because that's the part which has to go long way with you. Okay. So this is the list. Now, from chapter 17, any slide which students, any one of you wants me to do. Yes.
For the one you were just looking at, the question, why can't you do nitration before lithium diazonium?
Good question, because nitro is the metal direct, sweetheart.
Isn't NH2 ortho, isn't it? Wasn't there?
But it is I just not told you. It's a polysubstitution. Make sense? Any other question? You can tell me any slide from 17. I'll go one by one to every chapter. Yes.
For the second one here, it's only 3 steps because the way I'm like getting
You made a diazonium salt, you did CuCN and then you reduced it. 3 steps.
CuCN? Oh, okay.
Right, Virgil?
Okay. Because I was doing H3PO2 and then
You-
restarting.
That's why I said exactly what I said right now. That if I don't give you these questions, you'll always go other way around. And I want you to process that reagent. And how CuCN is just giving you the same reagent, right? Any other questions? Chapter 17, you can scroll through and you can ask me any question from 17.
Could you theoretically just keep going back and forth with benzonium salt and then CuCN and just make the chain longer or no?
You can only increase by 1 carbon.
Okay.
Oh, you need to say process again. You have to be right on the, it has diazonium is right on the ring.
Okay.
You can only have 1 CN.
For the try problem on page 8.
Page?
Page 8.
Page 8. Yes?
Why is the 5th compound non-aromatic?
Page 8 now?
Yeah, page
I'm too far. So now what's your question?
8. Why is the 5th compound non-aromatic?
Can I number it because I might not be. Yeah, now tell me which number.
Number 5.
It's non-aromatic.
Yeah,
Why? Because this carbon is sp3.
Okay.
I want complete conjugation of the ring. Like, suppose I made like this. This was the question I gave in the recitation. That this ketone can deprotonate so fast as compared to this proton. I asked this question in the recitation, guys, this proton deprotonates very fast. I didn't give you, I said circle the one which can deprotonate very fast. So what the student did? The student immediately saw the sp3 carbons. Do you see that? And I said, of course this one. This is definitely going to be aromatic now. Now I'm showing you how did I process it. The moment I deprotonate this guy, I made negative charge here. I said, wow, resonance. 6 pi electrons right in front of me. You see what I? This is phenoxide ion. I just deprotonated and said, oh, it's forming phenoxide ion, such a stable ion. You understand? So the moment I see in first question, in the third part, in the 5 part, the moment I saw that they are telling me sp3 carbon or nitrogen, I said, damn, they are absolutely non-aromatic at all. They don't have any aromaticity. Does make sense? Any other question? This is the recitation question. Yes.
So the compound 3 was that on
Again, same story. Look at this nitrogen, it is sp3. 4 bonds. You need a p orbital for the resonance to start. Conjugation everybody did. Everybody made those p orbitals, right? You made MO1, MO2, MO3, MO4, right? In 307. Everybody made that, right? I need a p orbital. And get a p orbital, you need to have sp2. Can't be sp3. 3 means I used all in sigma interactions. Does make sense? So that's how I do it. Good question? Any other question? Now everybody understands? Now, next exam also I kept this class nothing. And because this is the time when I said that they have tons of questions when we are processing the things. Bring it. And do not hesitate that my question is very stupid. No, I have to write an exam. You don't have to write an exam. And I need to be comfortable when I'm writing an exam. So I need my questions to be answered. And if it is not answered, then you are not doing good to me. I need my questions to be. So that's what I'm saying. Do not worry about it. It's easy, difficult, who cares? You ask your question, what's there on with you, that you wrote it, that this is my question. I don't think so I'm writing this. I understand this concept clearly. Any other slide? Otherwise I'll go to 50.